Let's continue with factor completely. Count the terms, 3 terms. So the AC method of factoring may be useful here since A is not 1. So to make our AC table, we're looking for A times C, 65 times 3. I believe that gives us 195. It's actually negative 195 because one of our factors is negative. And B is the middle coefficient, 34. And we're looking for factors that multiply for this number and add for this number. Okay, 195 is a rather large number, so it might be helpful to see what factors are in 195. We already know 65 times 3. Let's see if we can break that down into small. Well, we could divide by 3 here and get the number 65. I believe we could divide the number 65 by 5 and we get 13. And that gives us all prime factors. Now because this is a negative, negative 1's not prime, but we might just consider negative 1 as one of our factors. So what we need is to arrange these so that they add or subtract for 34. So let's see, we could try the original 2 factors, 65 times 3, but I don't believe they do multiply, so we could put a negative on that. But do they add for 34? No, they don't. Negative 65 plus 3. Alright, so we could try, let's see, 15 and 13. 15 and 13. Could make one of them negative and see they do multiply for negative 195. Do they add? No, they add for negative 2. So let's try another combination here. How about 39 and 5? Negative 39 and 5. Negative 39 and 5. Does that pair add for 34? Well, it adds for negative 34, so maybe if we just make the 5 negative and the 39 positive, that ought to be the correct pair. These do add for 34. That's the correct pair. We use that pair to split the middle term. Okay, so rewriting our trinomial, we have 65w squared. Split the middle term with these new coefficients, minus 5w plus 39w. Continue with minus 3. We can factor this by grouping now that we have 4 terms. Looks like group 1 share the terms here share a common factor of 5 for the coefficients and w for the variables. When we divide out 5w from group 1, we have 65 divided by 5, 13 w. Divide 5w from negative 5w, negative 1. Group 2 is going to start with a plus because group 2 starts with a plus. 39 and 3 have a common factor of 3. There's no variable common factor. So divide the 3 out, we have 13w. Divide 3 from negative 3, we have negative 1. And now we see we have a new common factor. 13w minus 1 is a common factor. Dividing that out leaves the factor 5w plus 3. And remember to check this by multiplying. Okay, multiply these to make sure that you get this back. That's checking your factoring work by reversing it with multiplying. Okay. Let's take a look at this factor completely. Okay, again we have 3 terms here. But a good thing to notice is that we have a squared s and a squared d, so we might check the coefficients. Is 64 a square? Is 49 a square? Yes, they are. So that means when we have pattern where we have a square plus 2ab plus another square, that factors into, this is a trinomial square and it factors into the square of a binomial. This is factoring by a pattern. Now notice that this one has a subtract in the middle, so the pattern that goes with subtract just has subtract in the middle, but it factors into the square of this binomial, a subtraction binomial. Alright, so I believe that this probably factors into a subtraction, the square of a binomial. Let's check. What do we square to get 49s squared? Well, we square 7 for 49 and s for s squared. What do we square to get 64d squared? We square 8 for 64 and we square d for d squared. Now, because this is a subtraction binomial, our second term is going to be negative. So let's put a negative there. Now, let's see, will that work for the middle term? Let's see, plus 2, let's see if it works. Okay, we're gonna check it. So we believe that that's what it, how it factors by the pattern, and in order to check that, we would multiply. Does that actually work? Okay, so that means 7s minus 8d times 7s minus 8d. Carry out the multiplication and you see that you get 49s squared minus 56sd minus another 56sd plus 64d squared. These are right, and when you add these two together you get negative 112sd, so that one's right also. And checking that way lets you know that you factored correctly by the pattern. Okay, let's look at this one. Factor completely. Let's count the terms here. We have a binomial. Okay, so factoring a binomial means that we definitely need to look for patterns. So let's take a look at that. We see a square here. So could we say, what is it we square to get 16a squared? We square 4a. Is there anything we can square to get 49? Yeah, we can square 7. So this is most likely, remember when we have a difference of squares, that's what we call this. It's a difference of two squares, then it factors into two binomial factors, one sum and one difference. Okay, so if this is our A part of our pattern and this is our B part of our pattern, then it should factor into 4a plus 7, 4a minus 7. Now remember, to check that, actually carry out the multiplication. Alright, and then when you do carry out the multiplication, you get 16a squared for the first term, negative 28a, positive 28a, and negative 49. And the middle two terms are opposites and add for 0, leaving you the two terms that you had in your original. So this does prove that we factored correctly by the pattern. Okay, this is the correct factoring. It did fit the pattern. Okay, let's look at another factoring by pattern. Okay, here we see two terms. So again, if we have a binomial and we're factoring, we definitely need to look for patterns. This time I see the exponent 3, so we call those cubes. So we want to see if this is a difference of cubes pattern. A cubed minus b cubed factors into the pattern binomial a minus b, trinomial a squared plus ab plus b squared. Now remember, we learned these patterns a squared, ab, b squared, and then we learned the signs with the word soap. The first one is the same, the second one is opposite, and the last one is always positive. Same, opposite, always positive. We remember with the letters S-O-A-P. Alright, so now let's see if it actually does fit this pattern. Can we cube something to get the first term? We cube 3 for 27 and A for A cubed. Can we cube something to get the second term? We cube 2 for 8 and B for B cubed. Okay, so it does fit the pattern. So then this becomes the A and B part of our pattern. So our binomial is 3A, 2B. We'll wait and put the signs in later. Our trinomial is the square of 3A, 9A squared. A and B multiplied together, 6AB. And then our third term is the square of 2B, 4B squared. Now let's put our signs in. The same sign, the opposite sign, and always positive. Okay, and we could try for a while to get this to factor again. We see a square in the front, square in the back, but we can't find a factoring that will give us the right middle term, so we know we're correct in leaving this one as it is. Remember again, you could multiply these, and when everything cancels, you should have only these terms left, which will prove that your factoring is correct.